let's see. Hope you had a good weekend. A breather after your first 2 days back from the semester. I don't know about you guys, but I totally felt like I didn't have school today because I'd been off for so long and been home since we got sent home at like the beginning of November, so it's been a while. All right, so what are we doing today? We're gonna kind of finish up the hexagons assignment from last week. You should have all your vocab done today because that will make that next part a little bit easier. We're gonna start taking notes today. We are not gonna finish, is my guess, so we won't get to the density worksheet until, what is it, Wednesday, and then that's when the DOL will be due. So just kind of a heads up, a little behind my plan, but it is what it is. All right, hope you're ready to participate a little bit. So if you could please open up your, hold on, I got so many things up on my computer right now. Your assignment that looks like this. Was there any definitions that you guys had any trouble with finding or think that they're incorrect or you couldn't find a good one and I can help you out? All right. By your silence, I'm going to guess no. And so I'm going to move on. So, like I said, you were supposed to have the definitions done by today. And then today we were going to kind of refresh on this. I've uploaded it into, I was playing around with it with my last class, some different ideas. We're going to kind of work on putting a few of these together. All right. So the reason I've uploaded it up into Office 365 is to remind you guys, if you've forgotten over break, because I've forgotten everything over break, how to share a document. So when you've uploaded it and you click on share, you just, and I come right up, or at least my last name, I come right up. All right. Oof. I'm sorry, Dora. I am recording, so hopefully you can come back to it later on. Good morning, Bev. So would somebody give me 3 words that they would put together or think that they are related? Give me 3 words. Move these all out of my way. All right, density, mass, and volume. Beautiful. I will love to go with that. Density and mass. Where did I put? Oh, up top. All right. So Bev volunteered density, mass, and volume. All right. And so when you guys share it with me, obviously you'll have one web. I'm actually going to pull up a couple other students really quick. Let's see. You guys can see what grading looks like from my end. All right, so this student just kind of made, I don't know, a crescent shape out of all of hers. And I have another one who did it very differently, but it's still good. Hold on, where is he? There he is. All right, where it kind of spreads out a little bit more. So remember that your whole goal is to have them all touching in some way, shape, or form, because all these words are related, okay? And it's just kind of how it relates in your head. Like me, I could relate density right back to mantle and make a complete circle out of this. So we all think of things a little bit differently. Oops. Where did my, there we go. All right, so we're going to go with what Bev said. We'll pretend that all of this is together. Ms. Peterson's going to make her arrow, and we are going to connect the terms, oops, density and volume, okay? Now, one thing I did do, let me get it so I can copy and paste it over, is I created kind of a sentence frame for you guys to use. Just to kind of, some of you like understood what it meant, but didn't necessarily have the words to put it together. Okay, so the first part is pretty easy. I chose to connect hexagons. Let's see. I'm just going to underline the words that I'm putting in so you guys can. What is one reason I might connect these three hexagons together? Somebody give me one reason. Why might I connect density, mass, and volume? I definitely would, that's for sure. Okay, I will definitely take that. So one reason connected these three hexagons is because mass, volume are a part of the equation. Very good. What's another reason you might connect some of these words? Maybe it's just like density and mass, or mass and volume, or volume and density, or all three of them. What other reason could you pick? Good. All right. I like that. Very nice. Math can affect and today. I'm sorry. Where everything's off. All right. What hexagon might you not connect to one of these? So I'll go back here so you can see the hexagons. Which one would you maybe not connect them? Like I showed you the one that kind of took the whole span of the slide. They had a lot of them that weren't connected to each other. Which ones might you pick? All right, just to honestly speed things along a little bit. One I might not, let's say, earthquakes and volume. Like, I honestly, maybe you can, but me personally, I can't think of something to connect earthquakes. I can't think of a reason to connect earthquakes to volume because they happen. Oh, I'm pretty sure I spelled that wrong too. No. Earthquakes happen regardless of what a volume of a tectonic plate is, or something like that. Okay. So this is kind of like a structure if you're having trouble getting some of your thoughts out. What you can do, I'm actually going to put it in the chat so you guys can copy and paste it into your work. So I would say at about 11:50, so about 7 more minutes, I'll give you guys time to work on this. So connect your hexagons, share it with me so I can put the arrows, right? And then I'll let you know so you can put your connections and turn it in. So till 11:50. Yes, we had these last week. You were just supposed to do the definitions, and then I was going to help you guys with this last week. Or sorry, today. Finish it up today. All right, Elizabeth, I put your arrows on. You're good to go. Oh, you're good. So displacement is, so for example, like if you're taking a bath and you sit in the bathtub, what happens to the water level? Yeah, it goes up because you're displacing that water. So ideally, if I had like a graduated cylinder in front of me and I need to find out because I can't measure maybe my chapstick really well, I would maybe put up to 50 milliliters of water, dump the chapstick in, and it would displace the water, it would move it up, and that milliliter difference, I would know exactly the volume of my chapstick container. So that's how we measure things that aren't like a square or a cube. You're welcome. So I would find a comfortable place to wrap up. We're going to move on to notes. So whatever you've got left to do on this is going to be homework. I have a feeling you'd rather that homework than the density worksheet. So that's what I'm going to try and keep moving a little bit. That is not what I wanted. All right. So in today's stuff, there's Unit 3.1 notes. We're not going to get through 3.1 completely today. We're going to do it again when I see you guys on Wednesday. So don't freak out too much. And like I said, we're probably not going to finish notes today, so I'm probably going to move this to Wednesday as well and kind of backlog things a day. Your unit note packet is right here, so you need to download that, save it to a place where you can find it continually over and over again. That way you can, every time we take notes, every day we take notes, it's there for you. You know exactly where to find it. Since you're all live here in class with me, please click on join.nearpod.com. I do have a typo in it, and I'll tell you guys where it is. And let me get you a code so we can all participate. Maybe. There we go. All right, your code is L9JRW. So this is, if I were you, I would probably split screen. So you have your note packet on one side and your Nearpod on the other. Remember, this is for the whole unit. I have separated your vocabulary kind of by unit, so you have an idea of where we're heading, maybe things you already know or don't know. And we're going to start right here with how do we find density. So the first few slides I'm going to go through, you're not going to be typing or putting anything down. Just know that, at least in your note packet. Thank you, Isaiah, for being so quick. And Leica. And Brandon and Bev. And Liliana. Good morning, Liliana. I don't think I said hello to you. Elizabethson. If you haven't noticed already, for those of you that have signed in, there is a little bit of delay. It is what it is. Nothing I can fix. It happens whether you're at home or you're in class. Got 6 out of 10 of you. 7 of you. Thank you, Zakaya. I forgot I was able to share a link like that. Totally spaced. I should have done that from the beginning. Oh, there's someone. C. I'm going to go with Christian, so you can ignore my last message. Alright, we're moving on. Alright, so Unit 3 is all about the dynamic Earth, and all that means is like how the Earth moves and how it was made, why it is what it is, I guess you could say. Right off the bat, we're going to be looking specifically at density and the layers, since the layers are sorted by density. Alright, so these were all part of your vocabulary words, and hopefully they were familiar. Mass, weight, volume, and density. So I would like you guys, I'll hide your names for now, like you guys to kind of think specifically just about mass and weight, okay? And tell me, a lot of people confuse the two. You can tell me the definitions, you can tell me the difference, either one of those. Give me an answer in here. Yeah, I got all 10 of you in, thank you. All right, I've got one answer in. Keep them coming. Good. I like this. I haven't gotten this yet. In pounds. There's definitely a big difference between grams and pounds. I know you guys are better than a 40% participation rate. We're getting there. Good. Very nice. As these last couple answers are coming in, a couple of the definitions I've been reading through mention like mass is how much there is, like how many atoms. Weight can change. So you could take your weight on Earth, it'll be one thing. I send you to Jupiter, you'll have the same amount of mass, but you'll have a completely different weight. So they are, like, we tend to think of them as the same thing, and on Earth they kind of are, but weight can change, mass does not. All right, so very good. All right, what is density? Density is the mass per unit volume of a substance. All right, so that is how much material is packed into a given space. Every single thing on this planet and outside this planet has density. So your cup of water has density, your macaroni and cheese has density, your cat has density, I have density, all right? When we're talking units of density, you're going to see grams per milliliter, kilograms per meters cubed, or grams per centimeters cubed. You're typically going to see it in the metric units. All right, and then everything is compared to the density of water. So some fancy person long time ago arbitrarily said water has a density of 1. All right, 1 gram per milliliter or 1 gram per centimeters cubed, whatever it may be. It's just, it was given a 1. If it's lighter or a lower number than 1, it floats in water. If it's heavier than 1, it sinks in water. So those of you guys that did the density lab last semester, that should be kind of familiar. All right. How do we find density? This is where I made a typo. Okay, on the very first line, it should say you need mass and volume, not mass and density. All right. So it should say you need mass and volume. You find the mass typically by using a balance or a scale of some sort, like a food scale. We have a couple of those here. I think we have a couple of triple beam balances, the things that kind of go like this. Or if you've ever gotten like a physical at the doctor's and they have those little metal blocks that they push around, and that's a balance as well. To find volume, there's 2 different ways to find volume. One of them is length times width times height, which is just like you would probably see in your math class. If it's something uneven, like if I was trying to take the volume of my pen right here and like this is like super hard to measure and whatever, I would, just like I was explaining to Leica early, I would use displacement, which is putting that object in water and measuring that change in water level. If I go too fast on the slides, guys, let me know. It's not like I can see you guys writing your notes. All right. Water, good old H2O. It is really unique on top of the fact that we've based the density scale off of water. Water's the only thing that is more dense in its liquid form. Usually when it's in a solid, you guys know solid, liquid, gas, right? Usually when it's in its solid, it's more dense, but water, it's the exact opposite, okay? That's why ice cubes float. If you made ice of any other substance that you could find versus a liquid version of it, the solid substance would always sink, okay? Water is most dense at 4 degrees Celsius for some reason. I don't know, but it's kind of weird. And then water freezes at 0 and boils at 100. So we have two different systems, density and temperature, that are based all off of water. Yeah, Isaiah, there is a solid for oil. You could think, depends on the type of oil, but like lard is a solid version of it, since fat is an oil. That's one way. As far as temperatures can go, just about anything can go to gas and anything can go to a solid from a liquid state. So it just really depends on temperature and pressure. The last blank from the last slide. I don't remember what it is in the Word document. Displacement, everything is compared to the density of water. Oh, wait. Hopefully that helps, Maya. And yeah, so Fahrenheit gets funky. Fahrenheit is 32 degrees to 212 degrees, if I remember correctly. So yeah, it's a weird system, and we're the only ones that use it. You're welcome. All right, quick 3-question quiz, multiple choice. The first one I will say is kind of tricky, so if you get that one wrong, it's okay. It was kind of worded weird. But go ahead, take a couple minutes and answer these 3 questions. Almost there. All right, last one I'm gonna assume is coming in. Like I said, don't be worried if you got the first one wrong. It was worded kind of funny. My disclaimer is I did not write that question. Before I'll unclick to show your name so you can see your score, where exactly you got. There you are. Like I said, don't be hurt about missing the first one. So what is density? It's how much material is packed into a given space. I would also accept this to be totally honest. It's just kind of one of those brain fart moments. We all have them. But I can't change it without deleting all of the Nearpods, so it's kind of annoying. What substance do we compare density to? Most of you guys got this correct. We always compare it to water, the 1.0 grams per milliliter. And water is more dense in its solid form, or in its liquid form than its solid form. Sorry about that. All right. Those of you that were with me last semester might recognize the DMV circle, the density mass volume circle. This is just kind of a reference, and I just copied and pasted it into your notes so that way you had it. Here's some common units that we'll be using today, and when I see you again on Wednesday, all of the equations. And honestly, if you can memorize the circle, it's easier than memorizing the equations. So in order to find density, if you imagine like covering up the D in that circle, if it's like written out, then you have mass over volume, which just like math class is like mass divided by volume, right? If you're looking for volume, you would cover up the V in the circle and it's mass over density. So that is mass divided by density. If you're looking for mass, cover up the M, the whole top half of the circle, and just like in math, when you have two things next to each other, they multiply, like 2x or whatever. That is like multiplying them. So in order to find mass, you would multiply these two numbers together. Yes, I can. Just remind me. All right. So we're going to use this, and we're going to go through some practice problems. All right, so these first three are, hold on, I'm going to pull up your PowerPoint. Like I said, I put this up here so you have it for reference. Don't forget your units. Your units are very important, and I may or may not going to try and trip you up on Wednesday on a couple questions. All right, so you're going to go through these three practice problems. We'll go through them one by one and put your work and your answers in here, and I'll try and do the same. Oops. All right, go ahead and give this one a shot. Density is 6 grams per centimeters cubed. Mass is 3 grams. What is the volume? Nice, I've got a couple submitted. So far, so good. Oh, I love the circled answer with the units. It's totally like my favorite thing ever. or squared. I like boxing them in personally. I do either. All right, I know a couple people have dropped out with internet issues. I'm going to pull up this one because it's showing. We have the density and the volume, or sorry, and the mass, and we need the volume. All right, 1/2 centimeters cubed is correct, or if you wrote it, I was going to say this one was written as 0.5, you think? That's perfectly good. 0.5 grams. Cancel out, your grams cancel out, so you should have centimeters cubed left up here. And on Wednesday, I'll put up my phone as a document camera and actually write it out and kind of show the canceling and all that, and maybe it'll make things make a little bit more sense. There you go, 0.5 centimeters cubed. Very nice. So when you're typing it in your packet, a little bit bigger. So we have, we're looking for volume that is equal to the mass, which is 3 grams, divided by 6 grams per centimeters cubed. And that gave us the 0.5 centimeters. Too worried about raising and lowering exponents at this point. You guys hopefully get the idea. So that's what that first one should kind of look like. All right. Those of you that are still in progress and coloring, apparently, it's, I think, just going to automatically submit. So we'll try another one. So now you're looking for density. You've been given a volume of 2 milliliters and a mass of 12 grams. So what is your density? Go ahead and take a couple minutes to do that. All right, got a couple submitted. We have our one person that doesn't like to show their work. Just gonna peek at some of your answers. All right, good. You guys looked a lot more comfortable on this one. So your correct answer is density, and I think, yeah, those of you that put your units on it did it correctly. So I'm just gonna throw this one up really quick because I haven't done theirs yet. 12 grams, which is the mass, divided by 2 milliliters, which is the volume, gives you a density of 6 grams per milliliter. So you'll be able to just knock that right out in your thing. 12. Oops. Liters equals 6. All right, so we're going to pause right here in the notes. We'll pick up with the rest on Wednesday, so we'll probably do a lot of notes on Wednesday, to be honest, and do some more density practice. I've already been working out the problems, so that's what I was doing earlier. If you guys don't have any questions, have a good rest of your day, and I will see you on Wednesday.